Dumore Corporation is a manufacturer of fractional horsepower electric motors and power tools with plants in Boston, Wisconsin and Racine, Wisconsin. Dumore has achieved a reputation for making high-quality products which are targeted at specialty applications. While Dumore has maintained a reputation as a high-quality supplier, this quality has traditionally come at a high cost. Today, however, Dumore is under increasing pressure from customers to reduce their prices, yet still offer small lot sizes on a frequent delivery schedule. Dumore recognized that to meet these challenges, they had to improve the productivity of their manufacturing plants. They decided to convert to just-in-time operations and chose the Boston plant as the pilot site for this effort. Dumore hired Arthur Anderson and Company to complete a productivity master plan for the Boston plant. This plan included an opportunity assessment, development of a plant-wide layout, a cost-benefit analysis, and development of a phased implementation approach.
The planning project focused on the review of the current operations to determine the best approach for implementing just-in-time manufacturing throughout the plant. As you can see, the plant was organized in a traditional fashion in which machines were arranged according to process and not product. The arrows trace the flow of a typical part from the first operation through final assembly. The distance a part traveled averaged 810 feet. Throughput time for one of these parts was 20 days. There were 32 open orders on the floor at a time, which resulted in 12,000 pieces of work in process inventory. Average setups on each of the machines ranged from 30 to 120 minutes. There were significant amounts of scrap and rework.
Dumore had three primary objectives for this project. The first was cost reduction. This was a requirement for maintaining profitability and long-term relationships with our customers. The second objective was lead time reduction. Customers are very sensitive to lead time, and we saw this as a good opportunity to gain a competitive advantage. The third objective was quality improvement. Again, customers demand quality products. While we have always had a reputation for quality, the cost of achieving it was often high. The primary objective in the planning phase of the project was to verify the benefits of the program and sell executive management on going forward with the implementation. We wanted to use the master plan as a guide during the detailed design and implementation phases. Upon completion of the planning phase, we received approval to proceed with the detailed design and implementation.
The scope of the second phase of the project was the design and implementation of a pilot cell to manufacture 2 1/16 inch armatures. These armatures are components of Dumore's highest volume motors and therefore have a major impact on the plant.
Let's trace the original production flow of an armature at Dumore before they implemented just-in-time operations. About 1 week before an armature order was released to manufacturing, a material handler in central stores kitted all the required materials. This required significant non-value-added activity, sorting and counting materials. When the kitting was completed, the pallet was placed on a shelf until it was needed. Once the order was released to manufacturing, a lift truck moved the kitted pallet from central stores to an area behind the stacker, the first operation on the production line. This central storage philosophy caused excess material handling and indirect labor costs. The operator moved the required components to the work center and carried out the stack and insulate operations. Keep in mind that an entire batch of armatures would be processed at each work center before being moved to the next one. A typical batch would range in size from 500 to 1,000 armatures. Not only did this cause excessive work-in-process inventory, it also produced a high exposure to quality problems. For example, if a problem occurred at the insulator and wasn't caught until the next operation, the whole batch often had to be scrapped or reworked. Furthermore, communicating problems wasn't easy because of large distances between operators on the line. When stacking and insulating were finished, The operator would move the armatures to a staging area 15 feet away. Then an empty cart and kitted components for the next order were moved to the stacker. For the next process, winding, the operator obtained an order from a staging area 15 feet away and moved it to the work center. Notice the time that the operator had to spend idle, waiting for the winding cycle to end. The large distances between machines prevented the operator from performing other tasks during this machine cycle. When all the armatures had been wound, the order was moved to the wedger. The workstation design at the wedger caused the operator to bend and reach while performing the operation. There was also significant idle time in this operation. When wedging was completed, the armatures were moved 12 feet to the commutator slot and press work center. At this station, a commutator was slotted and pressed onto an armature shaft. The armatures were then moved 15 feet to a staging area. The stuff, fuse, and tuck and tie work centers were connected by a roller conveyor. The stuffer operator would walk 15 feet and obtain the order from a staging area. The stuffing operation was performed and the armatures were batched on a pallet. After fusing, the armatures were allowed to cool and were then moved to the tuck and tie operation. Although the operators were only 3 feet apart, they were separated by the conveyor, which limited their flexibility. Because they sat down to work, the operators were fixed to their machines and thus couldn't perform other tasks. This, combined with widely varying cycle times for operations, caused a build-up work-in-process inventory between stations. After the tuck and tie operation was completed, the first test operator would remove each armature from the order and test it for shorts and grounds. Armatures that passed the test were placed on a large cart. Armatures that failed the test were placed on a pallet marked repair. They were then separated by problem type and moved to the repair area. If one armature in a batch was found to be defective, it was quite possible that all parts in the order were bad. There was no immediate feedback to the operator, who might have been responsible for the first error and all of the subsequent ones. It was even difficult in many cases to determine the cause of the defect. As you've seen, each operation in the old armature process required excessive material handling and work-in-process inventory. Many operators waited idly for machine cycles to complete, and communication and feedback among the operators was not easy because machines were located at considerable distances from one another. Several steps were needed to move Dumore's Mauston plant toward just-in-time operations. The first step was to analyze the flow of parts through the plant and identify candidate parts for the manufacturing cell that was to replace the traditional process. Equipment was selected and setup production was performed on each machine. Once the cell design was finalized, a mock cell was constructed. The operators reviewed the design and adjustments to it were made based on their suggestions. Storage areas were then designed and procedures were developed for scheduling the cell. Once the equipment was moved into place, the operators were trained in using the new cell. At that point, the cell went into operation and adjustments were made to fine-tune it. Today, all 10 major armature operations are performed within this manufacturing cell. Parts move from one operation to the next with no batching of inventory between workstations. This has eliminated the majority of work-in-process inventory, and it has minimized the risk of quality problems. Now, if a defect is discovered, the whole cell is stopped and doesn't restart until the problem is identified and corrected. This limits potential scrap and rework to a very few armatures. Operators now receive immediate feedback on quality problems, which facilitates quicker and longer-lasting solutions. With machines placed very close together, operators can perform multiple operations, which minimizes everyone's idle time. Each operator is cross-trained to perform any operation in the cell. Because assignments are rotated throughout the day, fatigue and monotony are minimized. As a result of work analysis, the cell can be run by any number of operators from 1 through 6, depending on the required output. This provides enough flexibility to meet the full range of production demands. Operator response to working within the new manufacturing cell has been very positive.
Dolores, what were some of your concerns when you were stacking and insulating parts the old batch method?
When I stacked the old method, I was always concerned about running a good part. If I didn't have my machine set up properly, the measurements would be off. I could run a whole lot, possibly 200, 300 parts, and we wouldn't know until the end. Where the cell concept, you know in a matter of minutes.
Julie, when you have a winding problem or a malfunction today, is there a sense of urgency on your part to fix the problem? Do you get help immediately from others or from within the cell?
Yes, because you got 5 other people that have to set theirs up right behind you.
Dave, has scheduling been made easier in the cell?
Well, in the cell method, it's a lot easier. In the batch method, you had to use sometimes 7 different operations. You could have 7 different jobs at them operations. Now, you come in the morning, you have one operation, one job at all 7 stations. Makes it a lot easier, a lot less hectic to remember all the jobs that are on the floor. You have a lot less jobs on the floor now. You know if you're running a quality part right away. In the batch method, sometimes we had maybe 500, 1,000 parts that were wrong before we caught it. Now we catch it within maybe 5 or 10 pieces.
Joanne, has scrap and rework been affected in the cell?
Oh yes, it's been greatly reduced. Mainly because now we are on to the operations as it's going through, where in the past I may not have saw that same part for 10 days after it was manufactured. And if there was a problem, it could have gone through the whole batch. Now we correct the problem as we manufacture.
Kara, how do you feel about rotation in the cell?
Break up the monotonous rotating and learning different jobs is more challenging. And then if you do have a problem, everybody knows somewhat about the problem, not just that person who usually runs it.
We are very pleased with the results we have achieved so far. We have implemented the 2 armature cells on this layout. We have already achieved significant benefits in the armature cell. Lead time has been reduced from 20 days to 10 days. Quality has improved 75%. 8 operators used to be required to process an armature, whereas we can staff the cell with 6 or fewer operators, resulting in a direct labor savings of 20%. Our work-in-process inventory has been reduced by 46%. While we are pleased with the results to date, we realize that we will not achieve all of the potential benefits until we complete the implementation of the master plan. This includes implementation of the remaining armature cells, field cells, motor assembly, and finally our racine machining plant. We found several advantages in working with Arthur Anderson and Company on this project. They provided a proven approach and focused their efforts on implementing just-in-time throughout the organization instead of a few selected areas. They managed the project to enable implementation in a short period of time. Most importantly, they also provided a transfer of knowledge which has enabled us to continue the implementation on our own.
The Dumore Corporation is a good example of the benefits that can be achieved through the implementation of manufacturing productivity improvements. They also prove that these benefits are not limited to large organizations. What is required is a well-planned, focused effort with the right mix of people and skills on the project. Arthur Anderson & Company has assisted hundreds of clients of varying sizes and in many different industries to implement just-in-time manufacturing. We would be happy to discuss the opportunities available to your organization and how we can help you achieve the benefits that other clients, such as Dumore, have realized.